Hello scientific people, how are you today? Today we are going to discuss about the discovery and the composition of the nucleus. So in 1903, Sir Ernest Rutherford he received Nobel Prize for the discovery of the nucleus. So Sir Ernest Rutherford had two students, Geiger and Marsden. You can call them as their assistants too. And Sir Rutherford actually suggested an experiment. And in that experiment, Geiger and Marsden were supposed to have a gold foil, a very thin gold foil, and they were supposed to bombard alpha particles on it. So these are alpha particles. Alpha particles are made up of two protons and two neutrons. So they are basically the nuclei of helium atom. So alpha particles are positive in nature and alpha particles are released from radioactive substance. So for this experiment, Geiger and Marsden, they selected bismuth metal. Bismuth is a radioactive metal from which alpha particles are continuously coming out, and those alpha particles were directed towards a very thin gold foil. So here we can see the atoms of the gold, and these alpha particles were bombarded on the gold foil. So it was like 10,000 alpha particles. Out of 10,000 alpha particles, most of the alpha particles, this is the expected path, and most of the alpha particles, they actually passed through the atom like this. This is the expected path. They went like this, deviated. And this angle of deviation actually depends upon how far these alpha particles were away from the positive nucleus. So we will not talk about the nucleus now because that is what is the discovery. And it was noticed out of 10,000, most of the around 9,999 alpha particles, they just passed by, suggesting that most of the space in the atom is empty. Only one of the alpha particle, it actually scattered back. That means it was supposed to go in straight line, but it had deviated by an angle of 180 degree. So this was the alpha particle which went head on towards the nucleus of the atom. It again scattered back. So this positive alpha particle scattering backwards suggests that there is something positive at the center of the nucleus, at the center of the atom. And that too is very, very small because only one of the alpha particle is getting scattered back. So in this way, this experiment concluded that at the center of the atom there is a positive mass, and that is very, very small because only one of the alpha particle is scattered back. So Rutherford gets a credit, and his students and his assistants, they got credit of discovering the nuclei. Okay, let's talk about the nucleus in quite depth. So here is a nuclei of an heavy element. Heavy element means it has got more mass number. So the picture would be rather clear if we talk about a nuclei having more mass number. So these are all protons and neutrons, and we can see that maximum chunk or more number of protons and neutrons, they are concentrated at the center, and as we go far away from the center of the nucleus, the number of protons and neutrons keeps on decreasing. So we can also actually plot a graph of density versus the distance. So this is the density versus the distance graph, and we see something like this. It actually meets the x-axis or r-axis at a very large distance. So this is the graph of density versus the distance. Distance is measured from the center of the nucleus. So we can see that at r is equal to 0 distance, that means at the center maximum density is there. Maximum density means more number of protons and neutrons. So as we go far away from the center of the nucleus, the protons and neutrons number, they decrease because the density is decreasing. So this is the maximum density. From here, half the density is somewhere over here, and if we find out the distance corresponding to half the maximum density. This is maximum density and this is maximum density by 2. This corresponding distance is called the radius. So the density of the nucleus is maximum at the center. So from here, maybe somewhere over here, the density reduces to half. So actually this is considered as the radius of the nuclei, right? Okay, so let's talk about the composition of the nucleus. So nucleus is made up of protons and neutrons. Protons are positively charged particles, neutrons are neutral in nature. These are subatomic particles. But remember, protons and neutrons are not fundamental particles. It is because fundamental particles are those particles which are not made up of anything else. But here protons and neutrons are made up of 3 quarks. So proton is made up of 2 up and 1 down quark, whereas neutron is made up of 2 down and 1 up quarks. So protons and neutrons, they are made up of quarks. Till today we don't know what are quarks made up of. So quarks are fundamental particles. Now, if we talk about quarks, they are definitely the fundamental particles. There are 6 types of quarks: up, down, then strange, charm, top, bottom. So there are total 6 types of quarks. We won't be going in much of the discussion about quarks, but up quark, single up quark has charge plus 2 by 3 times the charge of an electron, whereas down quark is negative in nature. So minus 1 by 3 times the charge of an electron. So if you talk about the charge of a proton, then plus 2 by 3e, plus 2 by 3e, minus 1 by 3e. So that's why the charge of a single proton is plus e. Means twice of this and one time the charge of this, and if you add it up, the total charge turns out to be plus e. In the same way, if you find out the charge of a neutron, then you will see that it is minus 1 by 3e, minus 1 by 3e and plus 2 by 3e. So that means the total charge becomes 0. Okay, fine. Now actually what holds these 3 quarks together in a proton or neutron are still smaller particles called gluons. So if you talk about a single proton, it is made up of 3 quarks, U, U and D. U, U, D. Now there are some kind of particles which are continuously being exchanged between these 3 quarks. So a small ball like particle goes towards this up quark from this up quark, again from this down quark to this up quark, and in all directions. That means there is continuous exchange of some kind of particles between these two and these two. Now those particles are called gluons. So gluons are again considered as fundamental particles. Gluons are continuously exchanged between these quarks, whether the quarks over here of the protons or the neutrons. So these exchange particles are what are holding these quarks together to make a stable structure of proton and neutron. Okay, so you might be amazed to know that less than 1% of the mass of protons as well as neutrons is contributed by quarks. Rest around 99% of the total mass of protons and neutrons is actually contributed by gluons, right? Okay, and talking about the masses of these up and down quarks, so we can use this formula, E is equal to mc square. So from here the mass can be written as E by c square. So we can measure the energies of the quarks, and we have found out that up quark, this is up quark, its mass is actually approximately equal to 2 MeV, mega electron volt, upon c square. In the same way, down quark is quite heavier. Its mass is almost equal to 4.5 MeV upon c square. Guys, you can also convert this mass into kilograms, because you can convert this into joules, and you can also put the value of c as 3 into 10 raised to 8 meter per second and the whole square. So you will approximately get this mass in kilograms as 4 into 10 raised to minus 30 kilograms. Okay, so these are the things which are to be kept in mind when we talk about nucleus. Hopefully guys, you liked my explanation, and do subscribe to my channel if you have not done so. So here is Kunal Mehta signing off guys. Thank you for watching the video.